This video is about parametric differentiation. If P is a point on a curve whose coordinates are x and y, and x and y are both functions of u, where u is called a parameter, this set of equations is called parametric equations. To get a set of points on the curve, you just have to assume values for u, and you'll get corresponding values for both x and y. Given these parametric equations, dy over dx, or the derivative of y with respect to x, is given by this equation. So it's equal to dy over du, or that is the derivative of y with respect to u. So we differentiate this equation with respect to u, times du over dx. That is the reciprocal of the derivative of x with respect to u. This can also be written as y prime. Also, the second derivative of y with respect to x is equal to dy prime with respect to u, or the derivative of y prime with respect to u, times du over dx. Note that dy over dx over here will still be in terms of the parameter u. And also, the second derivative of y with respect to x will again be in terms of the parameter u. Take note that we can use any variable to denote the parameter. Now let us apply this concept in our examples. In example number 1, given the set of equations, or these parametric equations, x and y are both in terms of the parameter t, so x is equal to 2 plus t cubed, and y is equal to 1 plus t squared. We find the derivative of y with respect to x using the formula above. So in the formula, we need dy over du, or the derivative of y with respect to u, and also the derivative of x with respect to u. So du over dx is the reciprocal of dx over du. Alright, so let's differentiate x with respect to t, because we are using t here as our parameter. So we are differentiating this equation with respect to t using power rule. We'll get 3t squared. And then differentiating y with respect to the parameter also, we'll get dy over dt. Using power rule again, we get 2t. Now, according to the derivative, the formula, dy over dx is equal to dy over, instead of using u, we are using t, dt, times dt over dx. Alright, so dy over dt is 2t. Dx over dt is equal to 3t squared, so therefore dt over dx, which is just the reciprocal of dx over dt, is equal to 1 over 3t squared. Alright, so dt over dx is 1 over 3t squared. This is dy over dx. Now we'll just have to simplify our answer. T over t squared is just 1 over t. So the final answer here is 2 over 3t. This is the derivative of y with respect to x. So you see here, the first derivative of y with respect to x is still in terms of the same parameter. Now if we'll have a follow-up question and we want to find the second derivative of y with respect to x, we use the formula dy prime over du times du over dx, where y prime is of course 2 over 3t. So we can also write y prime as 2/3 times 1 over t. Alright. So the derivative for the formula for the second derivative of y with respect to x is dy prime over dt. We are using t as the parameter, times dt over dx. So we'll be needing the derivative of y prime with respect to t. This is y prime. So it's still in terms of t. Now differentiating y prime with respect to t, I'll copy the constant 2/3, and the derivative of 1 over t with respect to t is negative 1 over t squared. Okay, using power rule, of course, when 1 over t is written as t raised to negative 1. Right, so dy prime over dt is negative 2 over 3t squared. Right, so the second derivative of y with respect to x using the formula is equal to dy prime over dt, where it is equal to negative 2 over 3t squared, times dt over dx, where it is equal to 1 over 3t squared. Now, simplifying the answer, the second derivative of y with respect to x is negative 2 over 9t to the fourth. This is the second derivative of y with respect to x. Now, in our next example, the parameter is z. So, y is equal to z over 1 minus z, and x is equal to z over 1 minus z squared. So, we'll find the first derivative of y with respect to x and the second derivative of y with respect to x. So, the first derivative of y with respect to x is given by dy over dz times dz over dx. Okay, so we'll need to differentiate y with respect to z and also differentiate x with respect to z. Okay, using quotient rule to differentiate y with respect to z, that's 1 minus z times 1 minus z times the derivative of 1 minus z with respect to z, and that is negative 1. So all over 1 minus z quantity squared. So using quotient rule. Simplifying, we'll have 1 minus z minus z times negative 1, so that's plus z over 1 minus z quantity squared. Okay, z minus z in the numerator is equal to 0. So dy over dz is equal to 1 over 1 minus z quantity squared. Okay, now it's time to differentiate x with respect to z. Using quotient rule also, where u is equal to z in the numerator and v is equal to 1 minus z squared in the denominator. So it's v times du, 1 minus z squared times du, where du is equal to 1 minus u times dv, where dv is the derivative of 1 minus z squared. So that's going to be negative 2z all over 1 minus z squared quantity squared. So simplifying, the numerator will have 1 minus z squared plus 2z squared all over 1 minus z squared quantity squared. So upon simplifying, combining negative z squared and 2z squared, we'll have 1 plus z squared over 1 minus z squared quantity squared. Okay, so if dx over dz is equal to this expression, then in the formula we need dz over dx. So dz over dx is just the reciprocal of 1 plus z squared over 1 minus z squared quantity squared. So that's 1 minus z squared quantity squared over 1 plus z squared. Right, so dy over dx is equal to, using this formula, dy over dz, well, it's equal to 1 over 1 minus z squared quantity squared. So this is dy over dz times dz over dx, where dz over dx is 1 minus z squared quantity squared over 1 plus z squared. Now take note that 1 minus z squared can be written as 1 minus z, 1 plus z. Alright, so we can simplify our final answer. That's 1 over 1 minus z quantity squared. And then 1 plus z minus z squared can be written as 1 minus z, 1 plus z squared. Okay? All over 1 plus z squared. Alright, so in this expression, both 1 minus z and 1 plus z are squared. So we'll have 1 over 1 minus z squared, quantity squared, times 1 minus z quantity squared times 1 plus z quantity squared over 1 plus z squared. Okay, now let's just divide 1 minus z squared by itself. So this will just give us 1, and upon simplifying, we get 1 plus z quantity squared over 1 plus z squared for the first derivative of y with respect to x. Now take note that this is y prime, because to get the second derivative of y with respect to x, we'll need the formula dy prime over dz times dz over dx. Okay, so we need to differentiate y prime with respect to z using quotient rule again. Here is y prime at the bottom. So in the quotient rule, you have the numerator is equal to u and the denominator is equal to v. So let's take dy prime over dz. Okay, look at the function below. So using quotient rule, copy the denominator, 1 plus z squared, times the derivative of the numerator. So that's using chain rule, that's 2 times 1 plus z raised to 1. Okay, so minus the numerator 1 plus z quantity squared times the derivative of the denominator with respect to z, and that's going to give us 2z all over the denominator squared. Alright, now we'll just have to simplify. So what I'll be doing is remove the grouping symbols, all the grouping symbols in the numerator. Now it will be easier if we factor out the common expression between the two terms from the numerator, and that is you only have two terms. This is the first term. This is the first term. And then this is the second term. Okay, common factor between the two is 2, 1 plus z. Okay, factoring 2 and 1 plus z from both terms. In the first term, we'll just be left with 1 plus z squared. This expression. Now, in the second term, so minus 1 plus z is factored out. So, you'll just have from 1 plus z squared, you'll just have 1 plus z. And then 2 is factored out from 2z, so you'll just have z. Okay, all over the same denominator, 1 plus z squared, quantity squared. Okay, now let's remove the grouping symbols inside the bracket. So 2 times 1 plus z. Okay, that's 1 plus z squared minus z upon distribution. Okay, minus z squared. Okay, combine like terms in the numerator. So that's 2 times 1 plus z. Combining like terms, we'll have. So this is what we'll have after combining like terms. Okay, then multiplying 1 plus z and 1 minus z in the numerator, we'll have 2 times 1 minus z squared. Okay, over 1 plus z squared, quantity squared. Okay, this is dy prime over dz. Alright, so now we'll get the second derivative of y with respect to x using the formula above. So it's dy prime over dz, where it's equal to 2 times 1 minus z squared over 1 plus z squared quantity squared multiplied by dz over dx, where dz over dx is still 1 minus z squared quantity squared over 1 plus z squared. Okay, just simplifying our answer. Second derivative of y with respect to x is equal to 2 times. So 1 minus z squared times 1 minus z squared squared would be 1 minus z squared cubed. And then the denominator multiplying 1 plus z squared squared and 1 plus z squared, will get 1 plus z squared cubed. Okay, this is the second derivative of y with respect to x. Now on to our last example. So if x and y are in terms of theta, so x is theta minus sine theta and y is equal to 1 minus cosine theta, we find the first and second derivatives of y with respect to x. Alright, so we'll differentiate x with respect to theta and also y with respect to theta. Okay, derivative of x with respect to theta is 1 minus cosine theta, while the derivative of y with respect to theta is positive sine theta. Okay, differentiating this will get positive sine theta. So the derivative of y with respect to x using the parametric differentiation formula, that's dy over d theta times d theta over dx. So if dx over d theta is 1 minus cosine theta, then d theta over dx is equal to 1 over 1 minus cosine theta, just the reciprocal of dx over d theta. Alright, so substituting the expression equal to dy over d theta, it's sine theta, and then multiplied by d theta over dx, which is 1 over 1 minus cosine theta. So dy over dx is equal to sine theta over 1 minus cosine theta. This is the first derivative of y with respect to x. Now on to the second derivative of y with respect to x. The second derivative of y with respect to x is equal to dy prime over d theta times d theta over dx, where y prime is equal to this. Alright, so dy prime over d theta, using quotient rule for the derivative of y prime with respect to theta, that's 1 minus cosine theta times the derivative of sine theta, which is cosine theta also, minus sine theta, numerator, times the derivative of 1 minus cosine theta, which is the denominator, so that's positive sine theta, all over the denominator squared, 1 minus cosine theta, quantity squared. So removing the grouping symbols in the numerator, we'll get, okay, by distribution, we'll get cosine theta minus cosine squared theta minus sine squared theta, all over 1 minus cosine theta, quantity squared. Now factoring negative 1 from the second and third terms in the numerator, from these two terms, we'll have cosine theta minus the quantity cosine squared theta plus sine squared theta. And according to an identity, the expression inside the grouping symbol is equal to 1. 1 minus cosine theta quantity squared. So this is equal to 1 according to an identity. So we have cosine theta minus 1 in the numerator, and factoring negative 1 from the two terms in the numerator, we'll have negative of 1 minus cosine theta over 1 minus cosine theta quantity squared. Now dividing 1 minus cosine theta by 1 minus cosine theta squared, so we'll just have 1 over 1 minus cosine theta. Okay, this is dy prime over d theta, negative 1 over 1 minus cosine theta. Right, so for the second derivative of y with respect to x, using the formula here, it's dy prime over d theta, where it is equal to negative 1 over 1 minus cosine theta times d theta over dx, where it is equal to 1 over 1 minus cosine theta. Okay, simplifying our answer, second derivative of y with respect to x is equal to negative 1 over 1 minus cosine theta quantity squared. This is the second derivative of y with respect to x.